Hello everyone. In this video, I'm going to solve Cambridge O-Levels Additional Mathematics Paper 1 in a session May-June 2019, Paper 1-1. So let's start with question 1. Question number 1 in A part, on the Venn diagram below, shade the region indicated. Okay, so A intersection B and union with C. So A and B, and the intersection of A and B is this, A intersection B, and its union with C. So this whole C is shaded and this section is shaded. So let me do this. So basically we have to shade this whole C. Plus this section. Right. Now for the second one, A complement union B. A is this and A complement is outside of A and its union with B. This is this portion and its intersection with C. So only this portion of C, right? Okay, let me explain again. A complement is a region that is outside of A, the whole region, and it's this region union with B. So this B, right? And its intersection with C. So this B intersection with this C. So this portion is in A, so which is not including. So let me shade this one. So this is included region. This portion is not shaded because it comes in A, right? Now for part B, on the Venn diagram below, draw sets P, Q, and R such that P is contained in R, Q is contained in R, and P intersection Q equals to phi. Okay, so it means P is a set which is in R, which is contained in R. Q is a set which is contained in R, right? So let me draw the big set R. The big circle. Okay, so this is the set R, right? Now P is inside of R and Q is also inside of R. Now, so I drew the big set R. P is inside of R, this is P, and Q is inside of R, this is Q, right? And P intersection Q, this is equals to phi. So that's the Venn diagram that satisfies the given condition. Question number 2 in part 1. Write down the amplitude of this function 4 sine 3x minus 1. So amplitude is the absolute of a value. So in our case, amplitude is 4. Now for second part, write down the period for this. Period is a sine curve. Sine period is 360. Divides the b value. B value is 3. So what is 360 divides 3? So 360 divides 3. This is 120. So 120 is the period, the one complete cycle. Now for third part, on the axis below, sketch the graph of this function for x is between minus 90 degree to plus 90 degree. Okay, to graph the sine function, there are a few steps that we have to follow. So let me write down this function. So we have y equals to a sine b x minus d plus c. This is the transformed equation and this is a given one. So let me compare with the given one. Y equals to 4 sine 3 x minus 0 minus 1. Right. So the first step is to find the amplitude. So we know the amplitude is the absolute of a value, that is equals to 4. Okay, now let me find the second, that is equation of x's. Equation of x's is the c value, that is minus 1. Right. Now we have amplitude, we have equation of x's. We can easily find the maximum point of the curve and the minimum point of the curve. Okay, so maximum has a formula. that equation of x is plus amplitude and equation of x is minus amplitude. -1 plus 4, 3 is the maximum point of this curve, and -1 minus 4 minus 5 is the minimum point for this curve, right? Okay, now the next thing is the period. We got the period from the second part, that is 120. So period is 120 degree, right? Now point number 6 is the phase shift. Phase shift is basically the starting point of the curve, so that is the d value. So in our case, the d value is just 0, so we can say d equals to 0, or we can say the phase shift is 0, right? Now we can find the distance between points. Distance between points has a formula, period divides 4. Period dividing by 4, that is 120 divides 4, and we have 30. Yeah, 4 times 3 is 12, that is 30 degrees the distance between points, right? Now the point 8 is the x coordinates. So keep in mind, x coordinate starts with a phase shift. We have the phase shift that is 0 degree, and then adding distance between point each time. So as you can see, distance between point we have is 30 degree, so we add 30 degree each time, right? So in 0, adding 30, we have the next point is 30 degree, and then 30, adding again distance between points, 30 plus 30 is 60, and then we have 60 degree plus 30, that is equals to 90 degree. So since we have the domain till 90, so we have to stop over here, right? And okay, now what are the y coordinates? Now let me find the y-intercept first. Yes, number 9 point is the y-intercept. Y-intercept is a point when the x coordinate equals to 0. So in the given curve, when x is 0, y equals to 4 sine 3 times of 0 minus 1. And we know that sine 0 is 0 times 4 is 0, y equals to minus 1 is the y-intercept, right? Now let me draw the curve for the sine function. Okay, sine function starts with the origin, and this is a curve, the one complete cycle of y equals to sine x, right? So as you can see, it starts with this point is the equation of x's, right? This is a maximum point, and then it comes to again equation of x's, then the minimum point, and then equation of x's, and then the maximum point, right? Okay, so this is a curve for the sine, the y values, these are y coordinates. So when the x coordinate is 0, this equivalent to the equation of x's. So we have the equation of x's is the c value in our case, that is equals to minus 1. C is minus 1. So we can say that the first coordinate is when x is 0, y is minus 1. Now for second, 30 degree, it must have a maximum point. So the maximum point of the curve is 3, right? At 30, it is at 3. Now for 60 degree, it is again comes to the equation of x's, that is minus 1. And for 90 degree, the next point is the minimum, and the minimum point for the curve is minus 5. So that is minus 5. So these are the coordinates. Now let me plot these points onto the grid. So the first point is 0 degree and minus 1. When x is 0, y is minus 1, this point. When x is 30, y is 3. 30, it is 3. 1, 2, 3, this point. For 60, minus 1. For 60, minus 1 again. And for 90, it is minus 5. 90, it is minus 5, this point. Okay. So on same, this is for the positive side. Now we can do the same thing for the negative side as well. Now let me check the values of sine when it is minus 30, minus 60, and minus 90. So this is a function. So we have sine 3 times minus 30. No, it must be in degrees. Sorry. Yeah, now it is in degrees. 3 times 30, that is minus 90, right? So sine negative 90 and times by 4, subtract 1, minus 5. So it is at minus 5, this point. Now let's do it minus 60. So 3 times of 60 is 180, right? Sorry, 3 times 60. Yes, 3 times 60 is 180. So sine minus 180, that is 0. So just minus 1. So at 60 it is at minus 1. This point. No, this point is minus 1. Now for 90, 3 times of 90 is 270. And sine minus 270 times 4, subtract 1 is minus 3. So this is at minus 3. Sorry, the 3, yes, the top point 3. Yes. Okay, now let me connect all the points to get the smooth curve for this sine function. So it will start from this point. Make sure it passes through each and every point. Right, so this is the curve for the sine function. Question number 3, the polynomial p of x equals to this, where k is a constant. For part 1, write down the value of p of minus k. So just substitute x equals to minus k. So p of minus k is equals to 2 times minus k minus 1 into minus k plus k minus 12. So minus k plus k is 0. So this is just minus 12. Now when p of x is divided by x plus 3, the remainder is 23. Now for second part, find the value of k. Okay, so it means where this information gives us that p of minus 3 equals to 23. Right, and we can easily find the value for k. So let's do it. So just substitute x equals to minus 3. So 2 times minus 3 is minus 6, minus 1, minus 3 plus k, minus 12 equals to 23. Right, so here we have minus 7 times minus 3 plus k, minus 12 equals to 23. This is 21 minus 7k minus 12 equals to 23. And minus 7k equals to 23 plus 12 minus 21. Right. Let me simplify this. What is 23 plus 12 minus 21? That is equals to 14. So minus 7k equals to 14. And the k value is 14 divides negative 7. Minus 2. So k is minus 2. Now let me write down the polynomial. P of x is equals to 2x minus 1, x minus 2, and minus 12. Okay, now for the third part, using your value of k, show that the equation p of x equals to minus 25 has no real solutions. Okay, so this is a polynomial p of x. So we need to put it equals to minus 25. So p of x equals to minus 25. And if it does not have any real solution, it means its discriminant is less than 0, negative. Now let's see. The polynomial, this is equals to minus 25. So 2x minus 1 into x minus 2 minus 12 equals to minus 25. Now let me multiply. So 2x square minus 4x minus x plus 2 minus 12 plus 25 equals to 0. Right, here we have 2x square and the x terms are minus 4 minus 1 minus 5x, 25 plus 2 minus 12, 25 plus 2 minus 12, this is 15. So positive of 15 equals to 0. So this is a quadratic equation. Now let me solve the discriminant. That is b square minus 4ac. That must be negative. So b value is this, minus 5 square minus 4 times a value times the c value. Okay, so this is 25 minus 4 times 2 times 15. 4 times 2 times of 15, this is 120. 25 subtract answer, this is 95 minus 95. Since the discriminant is less than 0, so we can say that the equation p of x equals to minus 25 has no real solutions. Question number 4 in part 1. The first three terms in the ascending powers of x and the expansion of this can be written as this. Find the values of each of the constants a, b, and c. The first three terms we need to find. So 2 plus bx power 8. The first term is 2 power 8. The second, 8. The second term is 8c1, 2 power 7. The second term bx power 1. The third term is 8c2, 2 power 6, and bx power 2. So these are the first three terms. So 2 power 8 is 32. Let me double check. No, sorry, 256. 2 power 5 is 32, yes. Plus, what is 8c1? 8c1 is 8. 2 power 7, 128 times bx, plus 8c2. 8c2 is 28. 2 power 6 is 64. b square x square. Let me simplify again. So 256, 8 times of 128. 8 times 128, that is 1024. 1024 bx plus 28 times 64 is 1792 b square x square. So these are the first three terms and they can be written in this form, right? So let me compare it. So they said 256 plus 1024 bx plus 1792 b square x square can be written in this form. This is equivalent to this form: a plus 256x plus cx square. Okay, now comparing, so a value is, this is a constant term, so we can say a is equals to 256. Now comparing the x coefficients, these two we have to compare, right? So 1024b equals to 256 and the b value is 256 divides 1024. 56 divide 1024. 1 by 4 is the b value. Now comparing the coefficients of x square to get the c. So we have 1020, now this one, 1792 b square equals to c. Okay, so b square is square of answer and times 1792, 112. So 1792 divides to 4 square is 16. This is equals to c. So from here we can say c is 112, right? So the a value is 256, b is 1 by 4, and c is 112. Now for the second part, using the values found in part 1, find the term independent of x in the expansion of this. The term that is independent of x is a constant term or the term having x exponent 0, right? Okay, so we have to use the values as well. So this is the same expansion, 2 plus bx power 8 we did in the part 1. So the first three terms equivalent to this. Let me do this. 256 plus 1024 times b. Okay, 1024 divides 4. 256b, 256x plus this is 112 x square. Okay, this is multiplying with This is just a square, so we open the square to the 2x square is 4x square, right? And minus 2ab. So minus 2 times a times b, that is minus 12, and x is cancelled with x. Plus 3 square is 9, x square is x square, right? Now we need to find the term which is independent of x. So if 256 is multiplying with x square, we will get x square. So this is independent of x term. So 256 times minus 12, and then this is 1 over x square term, this is x cube term, this is x term, this is 1 over x term, x power 4 x square term, and this is a constant term again, plus 112 is multiplying with 9, x square is cancelled with x square, right? Okay, now let me simplify. 256 times minus 12, this is equals to minus 3072. 112 times 9, this is plus 1008, and subtract 3072, this is minus 2064. So we can say that the term that is independent of x in the given expansion is minus 2064. Question number 5. A particle P is moving with a velocity of 20 meter per second in the same direction as 3, 4. For first part, find the velocity vector of P. We need to find the velocity vector of the particle P. So we can say that the velocity vector is equals to its velocity, that is 20, multiply the unit vector, like the vector by its magnitude. So the vector, let me divide by the magnitude. So magnitude is square root of 3 square plus 4 square, and the vector is 3, 4, right? So this is 20 divides, simplify, 3 square is 9, 4 square is 16, 16 plus 9 is 25, and square root of 25 is 5. So this is 5 and 3, 4. Okay, so yeah, 20 divides 5 is 4, and now 4 times 3 is 12, and 4 times 4 is 16. So 12, 16 is the velocity vector for the particle. At time t equals to 0 seconds, P has a position vector 1, 2 relative to the fixed point O. This is OP, right? Now for second part, write down the position vector of P after t seconds. So we can say the position vector of P, let's say RP, this is equals to the position vector of P relative to the origin OP, that is 1, 2, plus t times, or you can take any parameter, a velocity vector of P that we got from the first step, that is 12, 16. So this is the position vector of P after time t seconds. Now for the next, a particle Q has a position vector 17, 18 relative to origin OQ. This is the point OQ at time t equals to 0 second and has a velocity vector of 8, 12 meter per second. Now for third part, given that P and Q collides, find the value of t when they collide and the position vector of the point of the collision. Okay. So in this part, first we need to find the position vector of Q after t seconds, like we did in the second part. So this is a position vector of P, right? Now the position vector of Q is RQ, we can say is the, like we did OP, now we have OQ relative to the origin, that is 17, 18, plus the parameter T times the velocity vector of Q, that is 8, 12. Right. Now we have given that P and Q collide. So if P and Q collide, we need to put RP and RQ equal, right? So we have 17, 18 plus T times of 8, 12. This is equals to 1, 2 plus T times of 12 and 16. So we need to find the value for T. You will make two equations. So 17 plus 8t equals to 1 plus 12t. Okay. So we have equation 17 plus 8t equals to 1 plus 12t. or you can use second equation, that is 18 plus 12t equals to 2 plus 16t. You will get the same t value from both equations, right? Okay, let me solve the first one. So 8t minus 12t equals to 1 minus 17. So we have 8 minus 12, that is equals to minus 4. Minus 4t equals to minus 16. And 1 minus 17 divides minus 4, that is 4. So the t value is 4. You will get the same t value from the second equation as well. Okay, so they said find the value of t when they collide. So the t value is equals to 4 when they collide. And the position vector of point of collision. So now we need to find the position vector as well. So the position vector is, you can put t in RQ or in RP, right? You can get the same position vector. Okay, so let me do the position vector. Position vector. If I can say 17, 18 plus 4 times 8, 12. Okay, 4 times 8 plus 17, this is 49. 4 times 12 plus 18 is 66. So this is a position vector of collision. Or we can check for this one as well, putting t over here. So we have t is 4, sorry. 4 times 12 plus 1, 49. So that is same. And 4 times of 16, add 2, that is 66. So this is a position vector of collision. Question number 6. The diagram shows the curve. This is the curve and the straight line intersecting at points P and Q, showing all your working. Find the area of the shaded region. Okay, so the shaded area is between the line and the curve, right? So when we have area between the line and the curve, so first thing we need to find the point of intersection of line and curve, that is P and Q. So the first thing is point of intersection of line and curve. Let me put the line and curve equal and solving the points. Okay, so the curve is 3x square minus 2x and plus 1. This is equals to the line 2x plus 5, right? Now let me simplify. So we have 3x square minus 2x plus 1 minus 5 equals to 0. 3x square minus 4x minus 4 equals to 0, right? Now let me find the factors, like 3 times 4 is 12. Okay, we have 3 times 4, that is 12, and we want minus 4. So 2 times 6 is 12, and 2 minus 6 is minus 4. Right, so 2 and minus 6. Let's break the midterm. 3x square plus 2x minus 6x minus 4 equals to 0. X is common. So 3x plus 2 is left, minus 3. 2. 2 is common because 6 and 4, 2 is a common factor. We have 3x plus 2 equals to 0. So the factors are 3x plus 2 and x minus 2 equals to 0. So from here the 2x values are x is equals to 2 and x is equals to minus 2 by 3, right? So we have x is equals to 2 is over here and minus 2 by 3 is over here. Let me draw. So here the x coordinate is minus 2, and here the x coordinate is minus 2 by 3. Right, now the next thing is we need to find the integration of this curve between the point minus 2 by 3 to 2, and the integration of this line between the point minus 2 by 3 and 2, and then we need to subtract line minus the curve because line is at the top of the curve, right? Now the third point is, sorry, the second point is we need to find the integration of the curve minus 2 by 3 to 2. Let me do first line. The line is 2x plus 5 dx, right? So we have 2x square by 2 plus 5x and integration minus 2 by 3 say to 2. So we have x square here plus 5x. Let me put the limits. So first 2 square is 4 plus 5 times 2 is 10. This is upper limit minus the lower limit is this square, so that is 4 over 9, and minus 5 times 2 is 10 by 3. Right, so 4 divides 9 minus 10 divides 3, that is minus 26 by 9 times minus 1, that is plus 1 plus 14. This is equals to 156 over 9. 156 divides 9. So this is the area under the line. Now the third step is we need to integrate between minus 2 by 3 to 2 for this curve. The curve is 3x square minus 2x plus 1 dx. Okay, so this is, let me do 3, and x square is x cube over 3 minus 2x square over 2 plus x between minus 2 by 3 to 2. Simplify, x cube minus x square plus x minus 2 by 3 to 2, right? Now substituting the limits, for starting with upper limits, that is 2 cube is 8 minus 2 square is 4 plus 2, this is upper limit, minus the lower limit is 2 cube is a minus 8 over 3 cube is 27, minus 2 square is 4 over 9, and this is minus 2 by 3, right? What is 8 plus 8 minus 4 plus 2? This is equals to 6, right? Now let me do this bracket first. So minus 8 divides 27 minus 4 by 9, 4 divides 9, minus 2 divides 3, and times with minus 1, right, and add 6. This is 200 divides 27, right? Now the last step, the fourth step is since the line is at the top and the curve is under, so first we have to do the area of a curve line subtract area of a curve, right? So area of line minus area of curve. So we got the area of line, that is 159 over 9. So this is 159 divides 9, subtract, this is for curve, 200 over 27. Sorry, here let me double check this area under the line. So this is 4 divides 9 minus 10 divides 3 is minus 26 by 9, and then times with minus 1, this is plus 26 by 9, and adding 14, this is 152 over 9. So this is not 159 over 9, so this is 2 here, right? So we have to use this over here. So this is 152 by 9, and then subtract it with 200 divides 27. So this is 256 over 27. This is the area of the shaded region, right? So we can say this is area of shaded region. Question number 7 in A part, we need to solve this logarithmic equation and we have a base 3 and base 9. So first we have to make the same bases using change of base formula here. So we have log base 3x plus log x over log 9. So let me use a base 3 equals to 12. Right, so here we have log 3x plus log base 3x divides, what is log 3? 9. Log 3, 9 is 2 equals to 12, right? So take an LCM, 2 is multiplying with this, so 2 log 3x plus log 3x divides 2 equals to 12. So 2 plus 1 is 3, log 3x equals to 2 times of 12 is 24, right? So dividing by 3 on both sides, 24 divides 3 is 8. Yes, sorry, 24 divides 3. Yeah, that is it. So from here we have log base 3x equals to 8 and x value is 3 power 8 and x is equals to, what is 3 power 8? 3 exponent 8 is 6561. So that is a value for x. Now for part B, we need to solve this logarithmic equation. So as you can see, the base is 4. So let me rewrite this. Log base 4 3y square minus 10 minus log base 4 y minus 1 whole square equals to 1 by 2. So the log base 4, it is in the subtraction, so we can divide. Log base 4 3y square minus 10 divides y minus 1 whole square equals to 1 by 2, right? Okay, now converting logarithmic form to exponential form. So 3y square minus 10 divides y square minus 2y plus 1 equals to 4 power 1 by 2. So 4 power 1 by 2 is square root of 4, that is equals to 2, right? So cross multiplication, 3y square minus 10 equals to 2 times of y square minus 2y plus 1. So here 3y square minus 10 equals to 2y square minus 4y plus 2, right? So shifting all the terms to the right side, 3y square minus 2y square plus 4y minus 10 minus 2 equals to 0. So here y square minus 4y minus 12 equals to 0. Sorry, this is plus 4y. So this is a quadratic equation in a variable y. So we can factorize this. 1 times 12 is 12, 2 times 6 is 12, and 6 minus 2 is 4. Y square plus 6y minus 2y minus 12 equals to 0. Y is common, y plus 6 is left, minus 2 is common, y plus 6 equals to 0. So the two factors are y minus 2 and y plus 6 equals to 0. So the y value is equals to 2 and y value equals to minus 6. Now which value is valid? We cannot take minus 6 because log of negative number does not exist. When you substitute y equals to minus 6 here and minus 1, so log base 4 minus 7, which does not exist, right? So we can the only solution is y equals to 2 for this logarithmic equation. Question number 8, it is given that f of x equals to 5 e power x minus 1 for x belongs to real numbers. Now for part 1, write down the range of f. So this is exponential function and it has the horizontal asymptote f of x equals to minus 1. So let me draw the graph for this function. Okay. If this is the xy coordinate, right? So y equals to minus 1 is the horizontal asymptote. Let's say this is minus 1. This line is y equals to -1. Right. Now let me find out the y-intercept. So the y-intercept is a point where x is equals to 0, right? So let me put x equals to 0. So e power 0 is just 1, and 5 minus 1 equals to 4. So 4 is the y-intercept. Let's say this is 4 here. Okay, now let me check the values. X value is positive and the negative. So if I check at -1, so e power -1 times 5 subtract 1, that is 0.83, or just 0.8 is rounding to 1. So when x is 1, y is closer to 0.1. Okay, for at -1, let me check at -4. So it means that it is 1, it is over here, this point, right? So if I do at -4 times 5 subtract 1, this is -0.9, so closer to 1, -0.9, this point. So this is the shape of the curve. Let me check at 1, e power 1 times 5 and subtract 1, that is 12. So y is 12. So the shape of curve look like this. This is the exponential curve. Okay, so from this curve we know that the range are the y values, right? So as you can see, all the y values are more than -1. So we can say the range is when f is greater than -1, not equals to -1, because 1 at 1 is horizontal asymptote. It does not equal to that, it does not touch, the curve does not touch that point, but it approaches to that point, right? Now for the second part, find f inverse and state its domain. Okay, so for f inverse we have the function f. We can say y equals to the function f of x, 5 e power x minus 1, right? Now switching the variables, this y with x, 5 e power y minus 1, and now we have to solve for y. So x plus 1 divides 5 equals to e power y, and now converting exponential to logarithmic form, we have to take natural log on both sides. We can say natural log of x plus 1 divides 5, and natural log of e is just 1, that is y, and this is equals to f inverse of x, right? And now we have to state the domain for f inverse of x. As we know that the range of f of x equals to domain of f inverse of x. So we got the range of f of x from the first part, that is f is greater than -1. So we can say the range of the function, the domain of f inverse, this domain of f inverse is x is greater than -1, right? So for domain we use a variable x. Now for the next part, it is given also that g of x equals to this for x belongs to real number. Now for part 3, find the value of f composition g at 1. First we need to find f of g of x. So this is f of g of x is x square plus 4, and f of x we have is 5 e power x square plus 4 minus 1, right? So this is the answer for f composition g. Now let me find the value f g of 1. So 5 e power 1 square is 1 plus 4 is 5 minus 1. So now let me simplify. E power 5 times 5 subtract 1 is 741.06, or 741, just 741. Now for part 4, find the exact solutions of g square of x equals to 40. G of x we have given in the previous part is x square plus 4. G square of x means g composition g of x. G of x. So g and g of x is x square plus 4, and again g of this is x square plus 4 whole square, and then plus 4, right? Okay, now we have to put this equals to 40, right? So we can say x square plus 4 whole square plus 4 equals to 40. Opening the square, x power 4 plus 2 times 4 is 8 x square, and 4 square is 16, plus 4 minus 40 equals to 0. Now here x power 4 plus 8x square, let me simplify this, 16 plus 4 minus 40, this is minus 20. Minus 20 equals to 0, right? So this look like a quadratic equation. We have to do the substitution over here. We can say let u is equals to x square, right? So we have u square plus 8u minus 20 equals to 0, right? Now we have to factorize this quadratic equation in a variable u. 1 times minus 20 is minus 20. We have to find the factors of 20. That sum equals to 8. So 2 times 10 is 20, and 10 minus 2 is 8. Yes. So u square plus 10u minus 2u minus 20 equals to 0. U is common, u plus 10 is in the bracket, minus 2 is common, u plus 10 equals to 0. Okay, now the two factors are u plus 10 and u minus 2 equals to 0, and from here we have u is equals to minus 10 and u is equals to 2. Now substituting back, the u is x square, so we can say x square is equals to minus 10, and from here x square is equals to 2, right? And here we cannot get any value because x value is plus minus square root of minus 10, which involves iota. Square root of negative number give us iota, so we are not dealing with this. We are just dealing with the real numbers because we have given that x belongs to real numbers, not the complex one. So this give us the complex number, right? So, and here x equals to plus minus square root of 2. So the only solution is this belongs to the real numbers. This does not, this solution does not belongs to the real number. This solution belongs to the complex number. So the only solution is x equals to plus minus square root of 2. Question number 9. In this question, all lengths are in centimeters. A closed cylinder has base radius r, height h, and the volume v. It is given that the total surface area of a cylinder is 600 pi, and the v, h, r, and h can vary. So we have given the surface area of a cylinder. So the surface area of a cylinder has a formula. Surface area of a cylinder is 2 pi r square plus 2 pi r h. Right? Now for part 1, show that volume of a cylinder is this, and volume of a cylinder has a formula that is pi r square h. Right? So first we have to use the given information that the surface area is 600 pi. So putting the values in this formula, so this is 600 pi equals to 2 pi r square plus 2 pi r h. Let me solve for the variable h from here. Right? So we have 600 pi, and let me take 2 and pi common. We have r square plus rh, right? And dividing over here, so we have 600 divides 2 is 300, and pi is cancelled with pi, so we have just 300 equals to r square plus rh, right? And now we have 300 minus r square divides r equals to the value for h, right? Okay, now using the information for the volume, volume is pi r square h, volume is pi radius square, putting the value of h, that is 300 minus r square divides r. So we can cancel this r square with this r and opening the bracket, so we have pi, this is 300, v equals to 300 pi r minus pi r cube. This is square and this is r, so this exactly matches with the volume, right? Now for the second part, find the stationary value of v and determine its nature. Stationary value of v, it means we need to find the derivative of v with respect to r. So v prime equals to 0. We will get the value for r. Substituting that r value into v, we will get the stationary value of v, and we have to determine its nature by this second derivative. So let's do it. So first you can find dv by dr. So this is 300 pi, r derivative is 1, and minus pi, r cube is 3r square, right? Now put this equals to 0. The derivative is equals to 0. We have 300 pi equals to 3 pi r square. And let me solve for the r value here. Okay, so 300 pi divides 3 pi equals to r square. So we can cancel the pi. 3 is cancelled with 300. We have 100 is r square, and what is the square root of 100? That is 10. So the r value is equals to 10. Now r equals to 10 is the stationary value, the stationary point. We have to put this into v to get the stationary value of v. So we can say v at 10 is 300 pi times 10 minus pi 10 cube. Okay, so let me simplify this. 300 times 10 is 3000 pi minus 10 cube is 1000 pi. So 3000 subtract 1000 is 2000 pi. This is the stationary value of v, right? Now the second thing we have to find is determine its nature. So we can get the nature by taking the second derivative. So d2v by dr square. This was the first derivative. So this is a constant term. Its derivative is 0 and its derivative is equals to minus pi 3 and 2r. Right. So basically this is minus 6 pi r. Right. So when r is equals to 10, so d2v by dr square at r is equals to 10, this is equals to minus 6 pi times 10. 6 times 10 is 60 minus 60 pi. This is less than 0. So it means the stationary point is maximum. When the second derivative is negative, it is maximum. Question number 10. When log y is plotted against x square, a straight line graph is obtained which passes through the point 2, 4 and 6, 16 for part 1. Show that y equals to 10 power a plus b x square where a and b are constants. So to the straight line graph, so we know that equation of straight line is y equals to mx plus c, right? So here the m is a variable b and they replace c with a, right? So now y is this is representing as y and this is x coordinate. So log y equals to m is b x square plus a, right? So this is the equation. Now let me find the values of a and b. So first we need to put the first point, that is 2, 4, when log x square is 2 and log y is 4. So 4 equals to b times 2 plus a. And for second point we have 6, 16. 16 equals to b times of 6 plus a. Right, now we have two equations. We can solve these two equations to get the values for a and b, right? So let me subtract the two equations. So if I subtract the two equations, we have to change their signs and we can easily cancel a, right? Minus, minus and minus. So we can cancel positive a and negative a, right? And 4 subtract 16 is minus 12 equals to, we have 2b minus 6b. So 2 minus 6 is minus 4b. And from here we can easily find the b value, that is equals to 3. Now substituting this b value into the first or second equation, we will get a. So let's say a equals to 4 minus 2b. 4 minus 2 times of 3, that is 6, and 4 minus 6 is equals to minus 2. Now a is minus 2 and b is equals to 3. Now let me substitute it back to the equation and we have log y equals to b is 3 x square plus a is minus 2, right? But we have to show this, so converting this log into exponential form. So this is base 10, so y equals to base 10 3x square minus 2, right? Now for the second part, find y when x is 1 by 5, 1 over square root of 3. So that's easy, just substituting the value of 1 over square root of 3, we will get y equals to 10 exponent 3, 1 over square root of 3 whole square minus 2, right? Further simplification, we have y equals to 10, 3. This is 1 over square root of 3 square is 3 minus 2. So 3 is cancelled with 3 and 1 minus 2 is y equals to 10 power minus 1, or that is just 1 by 10. This is 1 by 10 or this is 0.1. So when x is 1 over square root of 3, y is 1 over 0.1. Now for part 3, find the positive value of x when y is equals to 2. Okay, so y equals to 2, substitute over here. So 2 equals to 10, 3x square minus 2, right? Now we have to convert the exponential form to logarithmic form to get the value for x. So here we can say log base 10 2 equals to 3x square minus 2, only the positive value, right? Okay, now we have log 2 plus 2 divides 3 is x square, right? And to get the value for x, we can say here x is equals to plus minus. So we are just dealing with plus square root of log 2 plus 2 divides 3, the positive one, because the question says we only need the positive value of x, not the negative one. So let me simplify. What is log 2 plus 2 divides 3? Log 2 plus 2 divides 3 and square root of answer, that is 0.876. 0.876, round to 3 decimal place. Question number 11, it is given that y equals to this. Now part 1, show that dy by dx equals to this where p and q are integers. So y is a function with the product of two functions. We have to use a product rule in the derivative. So before I want to find the derivative of the two functions separately, d by dx of x square plus 1 is 2x, right? And d by dx of 2x minus 3 power 1 by 2 is, first we have a power 1 by 2, the base function is 2x minus 3, and power minus 1, 1 by 2 minus 1, and the derivative of base function is just 2, right? And 1 by 2 minus 1 is minus 1 by 2, and 2 is cancelled with this 2, so answer is 1 over square root of 2x minus 3. Now let me do the derivative now, the product rule, yes. So dy over dx is equals to, first function is as it is, the derivative of second function d by dx of 2x minus 3 power 1 by 2 plus second function is as it is and the derivative of first function. Just substituting the derivative we got here. Okay, now we have, this is x square plus 1 and times 1 over square root of 2x minus 3 and times 2x minus 3 power 1 by 2 and its derivative is 2x, right? Now let me take an LCM. So we have x square plus 1 and this square root is multiplying with the square root, so square root times square root is just power 1, so plus 2x is multiplying with the power 1 of this function, whole divides 2x minus 3 power is 1 by 2. Let me simplify this further. So we have x square plus 1 plus 4x square minus 2 times 3 is 6x divides 2x minus 3 power is 1 by 2. 4 plus 1 is 5x square minus 6x plus 1 divides 2x minus 3 power 1 by 2. So this exactly matches with 2x minus 3 power 1 by 2 and plus 1. So px square plus qx plus 1. So this is px square plus qx plus 1. P is 5 and q is minus 6. These are the integers. Now for the second part of question number 11, hence find the equation of normal to the curve at the point x is equals to 2, giving your answer in the form of ax plus by plus c equals to 0, where a, b, c are integers. Okay, so first let me write down the equation of normal. Equation of normal is y minus y naught is equals to minus 1 over m into x minus x naught, right? So first we need to find the point x naught, y naught. So we have given the point x equals to 2. So just substitute over here. What is y? So at x is equals to 2, y is equals to 2 square is 4 plus 1. 2 times 2 is 4 minus 3, power is 1 by 2. That 4 plus 1 is 5 and 2 minus 3 is 1 square root. So this is just 5. So we have the point x naught, y naught, that is 2, 5. Right, m is the derivative of this slope. M is basically dy over dx at x naught when x is 1, right? So we got the derivative from the first part, that is equals to this. So I'm just substituting x equals to 1 here, right? So 5x square, it means we have 5 times 1 square minus 6 times 1 plus 1 divides 2 times 1 is 2. Sorry, it's not 1, it's 2. Yes, x is 2. 2 times of 2 and then minus 3 and then square root, right? So let me simplify this. So 2 square is 4 and 4 times 5 is 20 minus 2 times 6 is 12 plus 1 divides 2 times 2 is 4 and 4 minus 3 is 1 and 1 square root is just 1, right? So 21 subtract 20 minus 12 plus 1, 9. So this answer is 9. So the slope is 9. Now let me substitute all the values into equation of normal. So the equation of normal is y minus y naught is 5 equals to minus 1 over m value into x minus x naught is 2. Now we have to write this in this form, right? So simplify it. Multiplying by 9 here, so 9y minus 9 times 5 is 45 equals to minus x plus 2. Shifting all the terms to the right side, 9y minus 45, sorry, to the left side, plus x minus 2 equals to 0. So x plus 9y minus 47 equals to 0. So this is ax plus by plus c equals to 0. A, b, c are integers, that is 1, 9 and minus 47. So that was the last question of our paper. If you have any queries, please let me know in our comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.